There, okay. Good morning, everyone. For those of you that just arrived, there's coffee and breakfast snacks this way, so help yourself. I'd like to welcome you to the second annual CI Days, brought to you by the Office of Research Cyber Infrastructure. I'm Dan Atkins, Associate VP for Research Cyber Infrastructure. We began last night with a reception and a very interesting set of posters describing some of the quite diverse and amazing set of computationally and data-intensive research work going on at the university. And we had a competition to select the best of these and make awards. There were a set of judges that made recommendations, and then we had a people's choice. And to make the awards based on the judges and the people's choice, I'd like to ask Dr. Brian Athey, who chaired the review process, to come forward and present awards which are pieces of paper and tangible financial resources. Brian?
Thank you. I think sometimes tangible financial resources can be pieces of paper. You know, last time my wife was asking me this morning, well, are you giving any tangible resources in that? And I said, well, gee, I don't know. So I was happy to say that we are. And you know, now, could I ask the judges who are here to stand up or raise their hand or something? I know there's Alex, yeah, Sean, great. Charles, great, thank you. Ken, yeah. So we had, and there were several others. And, you know, the posters were great. You know, they absolutely were. And I thought that the strength was, and building from last year, is that they were quite diverse and really covered all the gamut of applications in cyber infrastructure across campus. And I think should be a seed crystal for what we can do in the future to actually grow this endeavor with Orki and ITS and the other IT organizations. It's absolutely great. Now, you know, I also get to say the envelope, please. We do have an envelope. And there are 3 awards, the first place, second place, and third place. And really, they're all wonderful. And we're grateful for everybody's participation in this. Now, the first place award was absolutely incredible poster. It was called Cosmic Sky Machine for Dark Sky Survey. It's a catchy title if there ever was one. It did have that dark matter in there, and there was another dark matter. There was absolutely, Jim, one of your posters had dark matter, and Dan and Laura and others were asking me, gee, do you guys really have dark matter in genomics? And now he's saying no, but I said yes. So anyway, this poster, Cosmic Sky Machine, Brandon Erickson is the awardee. Brandon, are you here? Please, great. I gotta say, that is chair of the committee, and this was absolutely a great poster. It had everything in it that we really wanted to see. It had great science. It was comprehensible. The graphics were stellar. And it had the right links with cyber infrastructure, the data sharing, the collaboration, the use of Exceed, the follow on to the TerraGrid. It was all there. So congratulations for such a fine effort.
Thank you.
Super. Now, the second place award comes from a completely different area. I don't know how much dark matter is in there, but nevertheless, it's called the MBNI Cloud Plus, High Performance Computing Optimized for Omics Data Analysis and Biomedical Research. And Man-Hong Dai and Fan Ming, so we actually have 2 of these. I'm going to let you guys gravel it. I think they're going to split the tangible resources on this one across the 2. But this was a poster that is exemplified what can be done with a secure high-performance computing platform to serve an enterprise across the country. This being the Pritzker Consortium, efforts have been going on for a long time to study schizophrenia, major depressive disorder, and bipolar disorder with 5 or 6 collaborating sites around the country. It's been going for a long time, and I can truly say this, without the efforts of Fan and his group and Man Hong, supporting Stan and Huda Akil, co-directors of the MBNI, that consortium, which has raised at least, in my recollection, about $70 million, would not have happened. So this is absolutely great, and it shows what we can do with cyber infrastructure in the biomedical research space if we're clever about it. So is Man Hong or Fan here? I don't see either one of them. But they will be here later, and we will hold on to this. And I encourage you to take a look at all the posters out there, including that one. Okay, in the third position here, final, we have a poster called Visualization of the Human Envelope. I certainly enjoyed looking at that. It was an eye-opener. You know, 3D computing makes a difference, right? If you've got 2D kind of specifications where things go, it can only do so much. But these days, you can make a three-dimensional calculation. It's fast, it's relatively inexpensive, and it can be a game changer for the entire field of understanding, ergonomics and human environmental interactions. Matthew Schwartz and Janani Viswanathan are the two awardees. Matthew or Janani, are you here? All right. Oh, yeah, great. You know, this has the promise of really, the work has the promise of really, helping us to understand how things seemingly as innocuous but important as, making the best layout in a room for people with disabilities can be improved dramatically. Because, in the old days, as you described to me yesterday, it was like the draftsman and the pencil and the blueprint. Now it's your computing system and enabling the world to, frankly, quickly and rapidly compute what can be done to, actually make our environments better. So thanks a lot, and make sure Janani gets that as well. Thank you. All right. Why don't we have a hand for all the people that did the poster? It's absolutely great. We'll hang on to this and stick it back in the envelope. And Dan, thanks a lot for organizing, and the staff out there. One thing that was really great is, and we have to, Catherine and everybody out there, Sharon, and the whole works that had organized this, because I do these poster sessions a lot, and it was really a smooth going with the judging and the keeping the scores straight and everything. So let's make sure to give Dan's crew a big hand too.
Well, we will. We'll bring them in later. Thank you, Brian. I think you may have just earned yourself a permanent job. That was fantastic. Yeah, the Burt Parks of CI days, if some of you old enough to know what that means. Well, again, welcome to CI Days, and we're going to start in this first session to kind of update you on what's going on. I'm going to start and say a bit about the activities of the still evolving and new Office of Research Cyber Infrastructure. And then Laura Patterson, my colleague as an Associate Vice President and the CIO for the university, and the Office of Research Cyber Infrastructure is a joint venture between her office and the Office of the Vice President for Research. We'll give you a broader context of NextGen Michigan and how this activity fits within that. And then we'll go down a level of specificity, and Ken Powell, who has graciously recently accepted the role as faculty director of research services within ORCI, will talk specifically about the Flux services that are now up and going. And there are opportunities throughout the day to get more detail about using Flux, and we hope that you'll do that if you're not already using it. And then we put a good bit of effort recently into creating a new website for ORCI, which we hope you will help us evolve it in a way that actually it becomes a useful resource to you. Our goal is to enhance communication, awareness of resources within the university, but also to create a more unified accurate, actually, picture of the activities going on in computational discovery at the University of Michigan for the outside world. This is an important step. So we're just going to give you a top-level tour of that. So the mission of the Office of Research Cyber Infrastructure is to catalyze the provisioning and the use of leading-edge cyber infrastructure services to ensure that our academic community remains competitive in research and the associated learning. So its ultimate goal is to serve the faculty, the students, the staff, for which computational discovery, broadly defined, is important, and to provide value-adding services. It is a matrix structure. It's a small office that's not trying to build a big empire, but rather the word catalyze is quite appropriate. We're trying to bring together resources that already exist in the university in a more holistic, reinforcing way, and to fill gaps of competence and if we don't have them here already. So it's administratively housed. The budget resides within the Office of the Vice President of Research. We do now, in fact, have a base budget, a recurring base budget, so we exist in that sense. And we have a faculty steering committee, and that structure is undergoing some revision right now. We have some senior advisors. I also play the role of the steward on the IT Council, which is a new governance structure that Laura will say more about later. I also happen to chair that council, but doesn't come automatically with the job of the AVP for Research Cyber Infrastructure. So in that role, I'm trying to help the overall university strategy and investments in IT, looking out for particularly the interest of the research community. Then we have the on-site Flux facility, a contemporary cluster computer, and Ken Powell serves as the faculty director of services that includes Flux. Part of the model, of the matrix model, is to reach out to competency wherever it exists in the university and to support that and develop working relationships that make that expertise available to the entire university. And the prime example of that is in the case of Flux, which is actually provided under a cooperative agreement with the College of Engineering and with supplemental funding coming through ORCE. And then ITS, which Laura Patterson also directs in addition to her CIO duties, provides support services to that, purchasing, billing, helping to install new machines and upgrades and so forth. And that all resides in data centers and using network support that are provided under the leadership of Andy Palms in ITS. And then we have a set of unit liaisons that are liaison between ORCE and now most particularly the Flux facilities and the various units. But if there's not an explicit liaison yet for your unit, don't feel that you can't use it. We'll definitely, and Ken will talk about how you get in touch if you want to explore the use of the Flux machine in your work. We also, on the right-hand side in the blue circle, we are also trying to understand the use of these computational resources to add value across by brokering intellectual ties, events such as we have today. So we have this academic community engagement team with Sharon Gava, Catherine Lawrence, Maria Schiller-Edwards, Dave Lampe, and they've brought you CI Days. They're bringing you the website. They are putting together a program advisory committee and doing a variety of things to help you with resource discovery and special events. And we will invite you later to actually help define things that we could do. We do have some discretionary money to use for convening seminars, speakers, and so forth. Then we have Flux is a major part of the provisioning agenda we have right now, but it's not the totality of that. And so we have a project called Cirrus. I'll say more about it in a moment. It's an allusion to the cloud, but it actually stands for Computing and Information Resources for Research as a Utility Service. And under that, we are exploring data management and storage development services jointly with ITS, as well as looking at external cloud providers. We have a nascent project that I'll say a bit more about in a moment, the Google Platform for Research project, and we're exploring, as I said, commercial cloud services. The components of CI-enabled discovery and learning include, on the left, computational and data-intensive computing, but they also include data management, curation, federation, preservation of data, and they include connections to observation, sensing, activation, and they include all of that embedded in environments that support distributed collaboration. And of course, all of that requires training, both in the creation of these environments and in the use of those environments. So that's the comprehensive view of CI-enabled discovery that we are using. This term, all-quadrant organization, is simply reference to this 2x2 matrix of geographic time and geography versus time, same and different. We're in the same time, same place quadrant. But the right kind of cyber infrastructure platform enables the work of a knowledge community to occur in all 4 quadrants. And so the idea is to reduce barriers of time and distance and allow the workflow of a knowledge community to move gracefully between these different quadrants and to thereby try to accelerate discovery, broaden participation, and so forth. I just wanted to point out, it's often not explicitly mentioned, that one of the most exciting things about the cyber-enabled science movement are the amazing developments in sensing and observing technology, where we're moving to higher temporal and spatial resolution. I mean, you see that in your CCD digital cameras almost every year, and consequently, that's one of the major components of the exponential growth in data. Self-organizing sensor arrays, autonomous platforms. You'll see one example in a moment. Low power, locally generated power, lower cost, and exploiting nanotechnology. And we have a very nice example of that in the Ocean Observatory initiative that John Delaney will be talking about tomorrow. I noticed Sharon Gava sent to me just a couple of days ago this article from the our local engineering college's website about the work of Khalil Najafi, where they are actually developing sensors that could be mounted on insects. And the idea is that these insects could go into hostile environments and send back remote instruments. And not only are these sensors, that they carry out interesting functions and they're small enough to be mounted on insects, they actually derive their power from the motion of the insect wings and so forth. So this is just, I thought, a local example of some of the stunning things that are happening around sensing technology. I want to give you just a brief tour of the agenda. I know you can read it, but I just want to make some comments about the various components of the agenda in the context of the framework that I've just given you. We have, this morning, I'm delighted that we have a talk on NanoHub by Gerhard Klimek, who is here. Where are you, Gerhard? Over in the corner. And we really appreciate Gerhard being here. He's right in the middle of a recompetition, this is an example of a kind of an all-quadrant structure that's working on a global scale. And one of the most interesting things about his work is the extensive analysis that they've done of the impact of this distributed ecology, really. And so I think you'll enjoy that very much. Then at noon, we're doing something a little bit risky. We're having the term, how many of you have used Google Plus or know about Google Plus, the new social software? Well, If you haven't used it, I'm becoming a big fan of it, in particular of the so-called Hangout feature, which is a really excellent video audio conferencing system that seems quite robust and works well for meetings up to 10 people. Well, we're going to have a hangout with the majority of the assistant directors of the National Science Foundation at noon, all of which are personal friends and many of whom are associated with the University of Michigan. It's quite amazing, yeah. And Joan Faridi Mundi is actually from Michigan State, and so I've asked these friends and former colleagues, I was at NSF for a couple of years, to come in and just give you about a 10-minute perspective from their perspective and their disciplines about how CI-enabled science is emerging, and in some cases to talk about specific initiatives that are underway. Tim Kleen will be talking about some strategic things. So I hope that will work well. And then this afternoon, we have some sessions where you can really learn about available tools and resources. These are concurrent sessions. One of our goals is to, and one of the critiques we got from last year was to have more time for networking and interaction and crosstalk between people who attend there. So we hope that, you know, these break sessions you'll use, and we're having tomorrow. We're also having this Birds of Feather. Then tomorrow we have the second of the plenaries, which is this, I have never heard John give this talk, but people who have say it's an amazing talk. So I encourage you to attend that. Then we have a more kind of hands-on learning activities. The Birds of Feather sessions is an opportunity for people who have common interest to kind of self-organize, like the sensors I mentioned earlier. So start thinking about the Birds of a Feather session, and is there a way that they should initiate one, or if they want to lead one, or any guidance for how they go about it? Okay, I think we'll get some further instruction about how to do that. And then more concurrent sessions, and then finally, you notice in my opening framework I talked about data, and of course everything's becoming digital, and that's a great thing for many reasons. Digital data, digital computation, programs doing analysis et al. But as Victoria Stoughton will eloquently point out, unless we're careful, this actually creates a threat to the reproducibility of science, and unless we figure out ways to preserve the data and the codes that are routinely now used for scientific and engineering discovery, we run the risk of not being able to support the tradition of other people being able to reproduce these experiments. And then we'll conclude with a town hall session in which we'll explicitly try to get feedback and guidance from you for the future. So things to be thinking about. These are some of the things we'd like to hear, but we'd like to hear anything you want to tell us at the town hall about what topics and speakers you'd like to see in future CI Days events, or conceivably we could organize a special seminar along the way. What do you think of the portfolio of activities we have underway? What's missing? What needs to be reinforced? What needs to be tuned or modified of what we're doing now? What kind of support could we give you? And then, very important, what are you willing to give for the common good? I mean, what contributions would you be willing to make by sharing your expertise, giving presentations, organizing an ongoing special interest group, serving on advisory committees, that's all. So the CIRRUS project is the exploratory and advanced development part of ORCI, Computing and Information Resources for Research as a Utility Service. We've established the Shared Local Services Flux, which is really being run as a utility service. We're ongoing exploring trade-offs between local and emerging external cloud-based services, clouds as infrastructure and clouds as platforms for web services. And we know that some of you have been using Amazon and perhaps other other cloud services. If you have, we would really appreciate your letting us know that so that we can help get the benefit of the experiences you've had, and possibly at some future time there'd be some role we could play in aggregating demand or propagating experience from one place to another. So let myself or Sharon Gava or Ken know if you are have any experience with external commercially provided cloud services. And then we have a set of pilot projects, many being done jointly with ITS, and some of these being done jointly with other universities through Internet 2 or other industrial consortia. And there's also, I want to point out the evolution of the TeraGrid into what is now called the Exceed project. There will be a presentation on that. And then finally, the Google platform for research. Google, this is just new. It's some of it's still under non-disclosure. And so I'm a little guarded about what I can say. But Google is definitely on a path to extend and open its powerful platform to use by third parties. And the University of Michigan, through ORCHE, has been offered the opportunity to play a pioneering participation in this development, particularly in the service of research. And it so happens that one of my former students now is at Google and is in charge of this whole enterprise, and he's particularly interested in his alma mater being an early player. This would be particularly interesting for data-intensive work in, for example, genomics, proteomics, astronomy, natural language processing, social network analysis, and so forth. And so we're working now with Google to develop a solicitation for participation, which we would hope to get out early next year, and then to initiate some pilot projects, a few selected pilot projects to explore the use of this, what could be a potentially amazingly powerful platform. And we're not just talking about Google as an infrastructure service, not just for storage or even virtual machines in the sense of the Amazon services, but rather a complete stack of software and tools and interface tools and so forth, kind of in the spirit of the App Engine that you can also hear about right now, later today, that would make it relatively easy for scientists, non-computer science specialists, to create web services that would be particularly tailored. And underlying would be enormous computational and data storage capabilities. So if you want to make sure that you get information as this evolves, you can send email to Tracy down at the bottom, who is serving as the coordinator for this project. So we're going to now shift gears to Laura Patterson, who will give you the broader context. I want to note, Victoria, I gave a plug for your talk. This is Victoria Stoden, who just came in, and she's the one who's going to tell us about the threats to the reproducibility of science in the digital age and what we can do about mitigating that threat. So welcome, Victoria. Let's see, yours is in.
They said it's down. I don't know which one. No.
Does anybody know where? You're using PowerPoint, right?
I wonder if it's in downloads. Click on that. See if it's in there.
Yeah, there it is.
Good morning. Good morning. So as Dan said, I'm going to set some of what he shared with you in the broader context of what's happening at the university and our progress, and how the Office of Research Cyber Infrastructure and the Office of the CIO and ITS are working together to advance a strategy that has been established. So let me start by telling you something you already know. But for the past 15 years, the university has managed what we think of as infrastructure in a very decentralized way. And last year, we compiled an inventory of IT services across the campus and looked at those services as not just how many there were, but where they were being offered. Were they being run centrally? Were they being run locally? Were units sharing? This was important information as we thought about how we were going to go about building a robust research cyber infrastructure. And what might be of interest to you, this slide I know is very difficult to see, but what this slide showed that you might be interested in for today's context is that on the Ann Arbor campus, there were 44 email and calendar services, 82 different collaboration services, 131 storage services, and 37 high-performance compute services, just on the Ann Arbor campus. And so we recognize that for the university to advance and meet the challenges of today's science, we needed to step back and rethink about the infrastructure that supports the important work that goes on here. And so we created a vision, and when I say we, I mean IT providers across campus came together and created a vision that we are now executing on. It's actually a strategy that we call Next Gen Michigan. And this graphic explains the strategy that we are using. We start at the base of this graphic, and we spent some time thinking about how to achieve alignment and culture to the vision of a shared cyber infrastructure that enables collaboration, data sharing, data management, archiving of data, shared compute resources, because it's so foreign to the way we currently manage our infrastructure. And we did two very important things. One, we brought some central IT groups together to create a new IT group. But more importantly, we created a new governance model because a shared resource requires strong governance. And the governance model that Dan alluded to in his comments is a mission-aligned governance model. It is not aligned to organization hierarchy of the university. It is aligned to the mission of the university. And so we try to bring the research community together through the Office of Research Cyber Infrastructure as a conduit to understand the needs of the research community here and where the university should invest its tangible resources in order to build that cyber infrastructure that we envision. Once we had the governance model in place, the next thing we started to move on was how to rationalize the current infrastructure. How do we go about rationalizing 139 storage services? How do we go about rationalizing 30 to 40 high-performance compute services? And so we have started to work on shared service model, which, as Dan said, it isn't about bringing it to the center. It's about leveraging the expertise that is in pockets around the university and putting in place the Office of Research Cyber Infrastructure as the service broker so that to the researcher we can present a coherent set of services, whether they're coming from the College of Engineering, the medical school, ITS, or Amazon. And so we are now working, in fact, on rationalizing some of our infrastructure services. I'm going to very quickly highlight collaboration and storage. And then my colleague, Kim Powell, is going to talk about high-performance compute cluster, specifically Flux, as our shared high-performance compute resource. So the goal of what we're trying to move to is a shared cyber infrastructure, and one that is flexible enough that we can run shared services for an entire community, but that a researcher or a unit could also leverage for local innovations and edge technologies that are being created. The idea is that if we can offer a shared infrastructure, that we can innovate faster. We can move innovations more quickly to the shared infrastructure and make them available across the university. And so this is our vision for Next Gen Michigan. And Next Gen Michigan is in the cloud for two reasons. One, because it is emergent. We are defining it as we work with the community, and we expect that events like today, that new ideas will emerge that will inform us about what needs to be in our Next Gen Michigan infrastructure and environment. The second reason it's in the cloud is because we do intend and are already moving on leveraging cloud offerings. In fact, we believe that because in some areas we don't have a lot of infrastructure at the center, we can actually leapfrog to the cloud if we get the appropriate structures in place. So the idea is that the university's information technology investment should be focused on providing more externally provided, mission-aligned, and modern services that rapidly scale to meet the needs of collaboration, learning, and discovery. And so I want to explain or share with you just a couple of things that are underway toward achieving this vision. First of all, a group of people have come together and developed a cloud strategy. And the strategy is to move up the stack. Currently, we do have some virtualized offerings at the university, and they are at the infrastructure level. And we recognize that what researchers need, what students need, are platforms, not just infrastructure. They don't just need infrastructure that is physical data centers and servers. They need a platform on which they can develop things. And then above that, that we even want to deliver software as a service. And so part of our strategy is to move from the bottom of the stack up the stack to start offering platform as a service and move to software as a service. Secondly, we want to move from on-premise private cloud offerings to public cloud offerings wherever appropriate and actually as quickly as we can. But if we move to the cloud from our current distributed environment, we could create a lot of chaos. It could actually create bigger barriers to collaboration and data sharing. And so in many instances, we need to first come together to organize our current environment and then quickly move it to the cloud, putting the right protections around the data and how it's managed by the cloud providers. And what we envision is that we will have tiers of service offerings that offer various levels of protection, some on-premise and some in the cloud. So one of the first things, if you think back to the fractured infrastructure that I showed you, and I showed you 47 or 42 different collaboration services, one of the first things we are doing, and I hope you are aware of this, we are moving to Google as a collaboration platform. And that move starts in January. We will be piloting in January an @umich.edu domain that is actually running in the Google environment and provides you with email, calendar, and the whole suite of Google collaboration tools. But because it's in the UMich domain, it has connected to it our directory, which makes it easier to create groups, easier to find people, and invite them in to collaborate with you. We will be piloting that in January and February. We'll make it available to all students in March, and then we will start migrating faculty and staff from May through July. The second,
I had a question about Google. So is that for the inside collaboration or cross-team collaboration?
So the question was, is the Google for inside collaboration or cross-team collaboration? I would say both. It is for collaboration anywhere, anytime. The second thing that we are working on is our strategy around research data, both the storage and data management plans. And we are working from the work that came out of the Blue Ribbon Committee on Research Data last year. They published their report last year. It's available on the ORCI website. And we are executing to the recommendations in that plan. Actions that are underway are listed here, and what I would highlight is that we are moving forward with a proposal to do information lifecycle management, building a long-term data solution, that we will have tiered offerings that offer file storage to every individual that has an association with the university, data storage to every individual that has an association with the university, and long-term archival storage to meet the current demands for data management. We also are working to improve backup recovery while bringing down the cost of backup recovery and implementing what we call foundational enablers, such as robust identity management that allows for federated access so that data can be shared more easily across organizations outside of the university. The proposed approach that we will be moving forward with is that the library will actually be the service provider of data management planning and providing the support to the faculty. The library knows how to archive and curate information, and they will be building a service to offer to faculty for data management planning. We also have a proposal that looks to the health system, excuse me, either the medical school or the health system, as a service provider for data management planning for projects that involve personal health information. And ITS, or the Office of the CIO, will be the architect and the broker for the storage solutions. But the interface to the faculty will come through the library and other other areas that have expertise from across campus. So I'm going to stop there. I've talked about our progress on collaboration and our progress on data management and data storage. And now Ken Powell will be talking about Flux as our progress on shared high-performance compute clusters.
Let's see, I think it's up here. Is it? Here we go. I'll just use that one there. Oops. There.
Great, thanks. Thank you. Yeah, it is. Especially while I was editing my slides over there, and now I'm showing them without carrying them over here.
Yeah, both Ken and I are using the presentation part of the Google Apps Suite, which there's a new version now that's actually gotten quite useful. The first version was pretty hard to use.
I'll say in my own defense that Dan picked the colors and fonts. So, good morning, everyone. So I'm going to talk about Flux, which is a high-performance computing resource for campus, a shared resource that Laura mentioned in her talk. And I'd like to say that while I'm up here giving the talk, the material in this talk was primarily generated by Andy Carrot, who's the Director of Operations for Flux, and we had some feedback from the Flux liaisons, whom I'll mention on a later slide. So what we want to do with Flux is have a campus resource that is available for people who are doing data-intensive research and compute-intensive research. Now, not everything's going to fit on here. Obviously, we have to come up with sort of a compromise that we think will serve a lot of people's needs. It won't serve everyone's needs, but it's as close to a good general high-performance computing model as we have right now. And as Dan mentioned on his slide, I think he spelled this out pretty clearly. Basically, ORCI's kind of brokering an arrangement in which the high-performance computing group of Kane, the College of Engineering's IT group, has a long-time expertise in high-performance computing. So they're doing the operations of the cluster, and ITS is providing a lot of the core services, the data service support, the loading machines, the purchasing, things like that. And ORCI's kind of acting to broker this and then stand up the service and help communicate to people at events like this and through the website how they might be able to use this. As I'll mention, we're in the process of growing Flux. We're going to grow it in line with demand. So we have a plan for that. There are a number of things Flux is good for. There are compute-intensive problems that are explicitly parallel. People who work in this field either have developed their own software or can use packaged software that knows how to make use of multiple cores. Take a big problem and divide it up across many different computers. And if those computers are networked together correctly, you can do a much bigger problem than you could on your desktop. There are also compute-intensive problems that are what are called trivially parallel, where they can be divided among the computers and the computers don't really need to talk to each other. Both of those types of problems work well on Flux, and it's a good resource for that type of problem. Sometimes people have jobs that need to run for days at a time for whatever reason, and that's not very convenient on the desktop. So the sort of batch mode in which a resource like Flux runs is well suited to that. Also, some people have data-intensive jobs that just will not fit on a single desktop-type machine, and so they're using the fact that there's memory, a lot of memory associated with each of the cores on Flux to take their problem and divide it up that way, sort of based on memory. Now that being said, there are data-intensive jobs that are so data-intensive that they won't fit well on Flux, and there are compute-intensive jobs that are so compute-intensive that they won't fit well on Flux. But I'll talk a little bit about that later. Some of the things that Flux is not good for, just to be aware, it's not a solution for everything. Problems that need to be solved in an interactive mode are not typically well suited for Flux. That's what desktop machines are for, and because Flux is basically a shared resource that a lot of people are running on at a time, it's typically jobs are primarily run in batch mode. The other thing is it's not really meant for graphics. We do have graphics software on there. It can be the back end that does a lot of the number crunching to produce the images. But the job of rendering it on a nice graphics display is not really something that Flux is suited for. Also, Flux is a Linux platform, so if the software you're using is Windows software, unless you can find a Linux version of that software, it's not going to be well suited to Flux. Here are just 3 examples of the things going on in Flux. There are many projects going on in Flux at any given time, and I'm sure right now there are probably dozens of jobs running on Flux, or dozens of different projects running on Flux right now. So one, actually that's near and dear to my heart because I'm involved in it, is simulating radiative shocks that are generated by a really high-powered laser. Those shocks travel at over 100 kilometers per second, and it's a model of sort of physics of things that go on in supernovas or in inertial confinement fusion. And that's part of the CRASH Research Center, which is funded by the Department of Energy. So we do our computing on a lot of the big DOE computers for the really big jobs, and we do some of our development on desktop machines, but Flux is a nice middle ground for us where we can do a lot of runs, not the really biggest runs, but a lot of moderate-sized runs and turn them around more quickly than we can on the national lab machines. Dr. Abecasas, in School of Public Health, is developing tools, statistical tools, numerical tools for understanding genetic variation in humans, and with a particular focus on complex human disease. And in political science in LSNA, Dr. Mabane is developing tools, both statistical and numerical, for detecting anomalies in fraud in elections, called election forensics. There's a broad range of topics, things you wouldn't necessarily think of as running on a big supercomputer, a big high-performance cluster like that, that lend themselves well to that. The way people get involved in Flux is users purchase an allocation on Flux. Basically, they need to state up front, I want this many cores for duration of this many months. So that sounds like the onus is on the user to know how they're going to run, and to a certain extent that's true, although we can help them get some idea of how they want to do that based on our experience with other users. Also, because these allocations can be changed every month, the size of the allocation, it's fairly easy to come in and just say, well, let me start with 1 core and see if I can get my work done on that. Maybe I'll try 4 cores after that, 8 cores. So it's a nice way, especially like for a faculty member getting started, as the group grows, as the research group goes, to start with a small allocation on Flux and grow it up to dozens or hundreds of cores. And we've seen a lot of new faculty work in that mode. Come in the door, start with maybe an 8-core allocation on Flux and grow it up to a couple hundred-core allocation. And they're not on the line for buying equipment, installing equipment, anything like that. Users specify whom they want to have access to the allocation. So someone purchases an allocation and then says, and I want my 10 students and 2 colleagues to be able to have access to this allocation. So we have allocations that are just for a single user, but most of our allocations are for some group, maybe a small research group, or maybe an entire department, or even an entire college that could purchase an allocation and then make it open to a number of faculty or student groups. Users are billed monthly, and they're billed for their allocation as opposed to their use. This takes a little getting used to. It helps us in terms of planning, particularly now while Flux is a moderate size but not huge size system. We know if people are basically they're making a reservation, they're giving us a sense of how much of the computer they're going to use, and they're billed for that allocation. As I mentioned, they can change the size of their allocation each month if they choose to, and that's very helpful in terms of flexibility. Smallest allocation is 1 core month. It was hard to pick a level of detail for this talk because I know we have people in the room who are expert users of systems, HPC systems, and some people who've never really thought about whether their problem maps to this or not. So this is way too much detail for most of you in the room, but I know that there's a handful of people who want to hear this, so I included it. Flux is 4,000 cores. This may sound of a surprise to those of you who used it yesterday and saw 2,000 cores, but we are in the process as we speak, I think, of growing it from 2,000 cores to 4,000 cores. We have the machines and are loading them and getting them on the net. On each node, a node comprises 12 cores. There are 48 gigabytes of RAM, so there's 4 gigabytes for each core. And the nodes are connected by a quad data rate InfiniBand. There's a large amount of temporary disk space, 370 terabytes. And getting to and from Flux, because of the network infrastructure here on campus, is a 10 gigabit Ethernet data transfer. As I mentioned, the growth from 2,000 cores to 4,000 cores is going on right now, and our plan is, if demand is there, to grow this over the next couple of years to 10,000 cores. As I say, that's a lot of data. The bottom line is that there's a lot of cores, there's a lot of storage, there's a lot of RAM, and it's a lot of flexibility for you to be able to buy into that. I think for a lot of people, one of the prime drawing points is that there's a rich software library in there. Besides the kind of development tools, compilers, the OpenMPI library, Parallel Debugger, and Profiler, there's dozens of other packages, more than 100 right now, that includes many commercial packages. So it ranges all the way from things like Abacus and ANSYS that do modeling of structures and fluids, finite element type models, through things like R and MATLAB that are, R is a statistical package and MATLAB is a really general purpose computing tool that was developed by an ex-U of M professor and is now a big deal used by a lot of people, through things like VISIT, which does visualization number crunching, and VASP that does molecular dynamics. So for a lot of people, it's very nice. With their allocation of 1 core month, which is quite cheap, they have access to all these software packages. In addition, a user or a college or school or department can add their own software and make it available inside their allocations. So some of the advantages of using Flux. One is that it's, as I mentioned, it's dynamic. You can change your allocation each month and you can grow your allocation as your project grows, or if your growth is kind of cyclical, you can grow it and shrink it. So I think that that's really useful for a couple different classes of users. As I say, if you have a really high-powered users who use a lot of computing, they typically do some work on their desktop, some work on the biggest machines in the country, but they still find Flux as a useful middle ground because of the flexibility. Also, I think for people just getting started in this, the ability to, at very small investment, kind of dabble your toe in the water and then grow it to what you need for the capacity for the problem you're doing is really powerful. Also, there's some advantage to being local. For one thing, it's on the campus network backbone, so we have good connectivity to it. and the billing and reporting are done by U of M systems that we're all used to. We're in the process of upgrading sort of the reporting that's done so people get really good statistics and graphs about how they're using their allocation, which users are using the most of it, what their use looks like. So that'll help people plan what size allocations to buy better. I think very important, very helpful is that the support is local. If there's a problem or if you have a question, you can email Flux support, and that goes to both the operators and the help desk, and it also goes to the unit liaisons. So in engineering and LS&A, the med school and public health, and at U of M Dearborn, each place has a designated Flux liaison. Brock Palin in engineering, who's also very involved in the operations of Flux. In LS&A, it's Dr. Charles Antonelli. In the med school, it's Jeremy Hallam. In public health, it's Chris Scheller. And at UM Dearborn, it's Ryan Bankston. So this sounds a lot like a sales pitch, which it sort of is. I think we're making people aware of this service because we'd like to see it succeed as a shared resource for campus and be able to grow it. And as Laura mentioned, really get some economies of scale, but I think also get some community built around people doing these types of calculations. So one best way to get started really is to look at the two websites. We're propagating some of the material about Flux that's currently on the sort of on the operations portion of the website, HPC portion of the website of in the College of Engineering. We're propagating that over to the ORCE website. So that's one place to start. And the ORCE website has information about upcoming workshops and also some training materials that are posted there on the web. And of course, here at CI Days, there's a workshop, a hands-on workshop about using Flux that Dr. Antonelli is going to be running tomorrow afternoon, or tomorrow over lunch, I believe. And just getting started by emailing Flux support and saying, I'm interested, I'd like to get an idea what kinds of things, this is the problem I'm doing. That might lead to an email discussion, or it might lead to a one-on-one discussion with your unit liaison, or I'm happy to get involved too. That's one of the things I do, is sit down with faculty in particular, but other researchers too, who want to understand how their problem might map to this cluster and what kinds of tools there would be useful for them. Yes?
Just one correction here. Charles is going to be doing his session this afternoon at 1 o'clock.
I'm sorry, I got the dates mixed up. Thanks. Appreciate that. The rate is $18 per core month, which is close to the full cost of running it. Right now, that's been cost shared down to $11.20 per core month. I'm working with the associate deans for research and so on in the various units to see to what extent the units are going to be able to cost share that $18 cost rate down for users. So hopefully you'll be hearing something about that from your units going forward. So on July 1st, 2012, which is the fiscal year boundary, is when it goes up to $18 per core month. So thanks for your time.
So Dr. Sharon Gava is going to come up and give you a little tour of the website. While she's coming up, I just want to add a couple of comments. The deal that we negotiated with the provost office, which is really the funder of the ORCE enterprise, we have a base budget, and then we have a significant amount of one-time money to capitalize and buy the initial instance of the Flux machine. Flux, by the way, is a name I gave this machine. It's an allusion to a magnetic field that will pull us more to the center of a shared resource as opposed to this suboptimal individual machine. We've been instructed, and three of the big units, medicine, engineering, and LS&A, all contributed, were asked by the provost and agreed to contribute a significant amount of funding to the startup cost of the capital cost of it. And so it does represent a true partnership in that regard. We've been given guidance, though, by the provost that we are to recover the full cost of operating this machine. And we're doing that in as efficient a way as possible. I do want to underscore what Ken said about we're not just providing a bare bones machine the way many people do. We're providing an incredible portfolio of state-of-the-art software, and we're prepared to add more offerings, more titles to that as the demand grows. So if there's not a software package there, but something that you think you need, then you should let people know that. And I also, we kind of take, well, you know, the software's there for granted, but as I've learned from Paul Keeley and Deb Mattson from ITS, it's a huge amount of work that goes into negotiating licenses with the various software vendors. And there are people out there working very hard to get the best deal and to get the broadest use of this software available to you. And so we will, you know, all our licenses will be in compliance. There may be some terms that you'll need to be aware of about, you know, use with industry and others that you need to honor. And then finally, so the rate includes this enormous collection of software, and it also includes a refreshment of the machine, so that every 3 or 4 years the machine will be refreshed with you know, the next turn of the crank of hardware, and that in the highly distributed, personally owned machine era turns out to be an enormous problem. People come and negotiate startup packages and they get machines, but then a few years later they become obsolete. Then what do they do? So if you buy into the Flux Enterprise, you'll be getting a constantly refreshed machine. We've done a fair amount of benchmarking with these rates and what's provided by cloud providers and outside resources, and these are actually very, I think if you go do comparable comparison, you'll find, particularly if you factor in the refreshment of the environment and the software, that these are very competitive rates. And so these are the rates that we are in some sense wholesaling to the schools and colleges. If the schools and colleges have the discretion to decide, you know, whether to subsidize them or not, or to set up fund allocations that could be used for instructional use and so forth in the various schools and colleges. So, you know, if you should also make sure that your associate dean for research is aware of expectations or hopes that you have for the college, your particular college, helping out with making Flux available. So, Sharon, and then I think we'll probably have time for a few questions.
My name is Sharon Geva. I'm the Associate Director for Academic Community Engagement in ORCE. I know many of you personally already. If we do our job right in community engagement, I will get to know all of you. As Dan has mentioned, we really need to know what the needs are of the community as we go about building tools for the community or helping people broker with other services to let them do their job properly. We launched in mid-September our new ORCE website that is meant to be a meaningful part of the community engagement as well as a big part of resource discovery. We launched it at that time mainly as a platform for the CI Days registration, but we do also have some preliminary resource discovery content in it, which we will continue adding to all the time. The website is a work in progress, and it will continue to evolve along with the needs of the community, along with the requests we get from you and the feedback we get from you. The main idea is for it to continue to be an aggregator of all the information that someone who's involved in or is thinking of getting involved in CI-related research or teaching would need. I'm going to walk through very, very quickly, just a high level. I hope you can see the text on here. If you'd like to follow along, if you happen to have a smartphone or a laptop, our URL is orce.research.umich.edu. You'll be getting that on the magnet and the mug that you get as you leave today. And as an added bonus, if you have a smartphone and you scan the QR on the mug you'll receive, you will be taken directly to our homepage without needing to type anything in. Starting from the top, our About ORCE section gives the history and mission of ORCE. It gives a list of the people who are a part of ORCE, and also lists relevant reports that are about and from ORCE. We have 3 very informational sections of the website. The first one is about infrastructure. It's meant to aggregate data in general about CI, including what it is, how it evolved. We also have links, and we have definitions for CI. We have formative reports, and we have publications from U of M or from elsewhere, including institutions and organizations like the National Science Foundation. Our learning section lists, first of all, a group of CI-related courses at U of M, which we also are asking people to let us know about so we can add it in and keep it as fresh and current as possible. We also have online learning links, tutorials, workshops from U of M and from elsewhere. Most importantly, we have recordings from CI Days from last year, and starting late next week, we'll have the recordings from this CI Days, as well as the posters that were submitted to the poster contest. Our most comprehensive informational section is called Resources and Services, in keeping with ORCI's prime mission of being a broker and provider of resources and services. We've broken down this section by the different CI aspects to make it easier to find. We have things like collaboration tools, we have data storage information, we have HPC information. We include information about resources at U of M and elsewhere is an important thing to point out. Another thing to point out is that we include information both about the technology and about the human support for the technology. To make things easier to find, we also have this I'd like to section here down at the bottom. One of them is Get Support, where the list of contact addresses is basically broken out by the questions or comments you might have to make it easier to find us and to know who to go to. The other one is the Get Started, which breaks out the questions you might have about resources or learning or cyber infrastructure into the kind of questions you'll ask about. Our most frequently updated section of the website is a section called News and Events, where we post items about resources or events that are CI related. We actually rely on the U of M community for a lot of this information. Also, external communities send us information. We post them as we receive them. If you have something that you want to make known to people quickly and it's CI related, we have links that tell you where to send it to, and we can promise a very fast turnaround to get it posted. We have the most recent 5 items always posted on our homepage. We have the rest of the ones current from this month or archived, and a lower level here that you can get to. The important thing to know is you can subscribe by RSS to this if you want to get the items as they are posted. You can join our listserv here from our news and events page, and then you'll get roughly twice a month an email with links to items that are still relevant. Other things that are very important to us are the part about increasing visibility that Dan was talking about. To do that, we want to increase visibility both inward, meaning inside the U of M community, and outward. Dan mentioned it. The important part is that we have a very large community here at the university. You may not even know that there's someone in the building next to you who could be a collaborator or who has the expertise that you're looking for. The most kind of in front ways we're doing it are 2 sections here on the homepage. One of them is our featured research image. You can see one here that is actually relevant to CI Days. And we also have a featured research article. Both of these get archived, so we want to change these as often as we can. If you've missed 1 or 2 and you want to see the images or articles that you missed, they're all archived here. It just gives you a snapshot of a very short snapshot of what people are doing. The other important thing we've been doing over the past year, we've talked to about 70 groups and individuals at the university about their research. What we're trying to do is create a database that will be accessible from this website. In a future phase, it will have tags or keywords attached to each group or individual that will allow you to search by some kind of technical resource or by methodology or by interest areas, anything that would help you find someone who can help you in your work. At this point, what we've done as a first phase is basically list the people we've talked to. We've divided up into research centers versus research groups. But all of these are people at U of M who are working in CI-related research or teaching. If you'd like to be included in this group as a first way of getting some exposure for your group, we have links here. You can send us email, and we'll be happy to come out and talk to you. One last thing, if you would like to submit images for our homepage, we have an I'd like to submit a homepage image. If you'd like to submit a research or have us come out and write up a research article about you, we have those contacts in our Get Support or Get Started. I just want to stress again that the most important part for us is the community input. We get all our ideas, our input, we get feedback, good and bad, from the community, and we'd like to hear especially about things that make this website harder to use or easier to use, whether you've succeeded in using it, and any other input you can send us. So thank you, and enjoy the rest of CI Days.
Thank you very much. Again, I want to underscore, we'd like to develop as complete a list of the activities underway. So if you have a website for your project that's not there, I mean, as a minimum, let Sharon know that so that it can be added. And then over time, we might, aggregate things in some new ways. But as a minimum, we want to just have a list of, because I can tell you from our, my tour at NSF, which gave me really an international platform of activities, awareness, that, Michigan's reputation in this general area is not as strong as it should be based on the reality of what we're doing here. And I think we're trying to make, and to be blunt, a kind of a general reputation is actually a factor in reviewing proposals and so forth. So there could be a collective advantage in us coming together to enhance the general image about the exciting things underway here. Also, if any of you would be interested in moderating a blog or moderating a column or somehow, playing a role in kind of an editorial or moderator role in some particular field or subfield or aspect of cyber-enabled discovery, don't hesitate to step forward and offer to do that. And if there's some modest levels of support that you would need to do that, we could talk about providing that. So we have a few minutes. If you have questions or comments for Ken, Laura, or myself, this would be a good time to bring them up. Are there any questions or comments? Okay.
With the Google migration, what's going to happen to the Exchange server on campus? Is that the Exchange server? Are we switching over to the Google Calendar or?
Okay, that's a Laura.
So the question was, with the Google migration, what's going to happen with the Exchange service on campus? And are we switching over to Google calendaring? And the answer is yes. The goal is that, excuse me, Google collaboration tools will be used by everyone, or available, will be provided to everyone in a UMich domain. That Google email and calendar will be provided to all students and all faculty and staff except for the health system. The health system will continue to use Exchange because of EPHI, because of HIPAA compliance. And those units outside of the hospital who have staff who handle HIPAA data, we're working with Medical Center IT that their service would be provided to anyone who has to handle HIPAA data. So there would be one instance of exchange not run by ITS, but run by MCIT for people who need to handle HIPAA data. But even those people will have access to and use Google collaboration tools.
One further question on that. So are there plans to be able to see like free busy calendar-wise between the health system and Google Calendar? Is that underway?
So the question is, are there plans to see free, busy calendar between the health system and between the Exchange users and the Google users? And right now, the answer is no. We did quite a bit of analysis on that, and we've talked to other places that have implemented. And there was a concern from the health system that if patient information were on a calendar, it could then get exposed and end up in the cloud. And so if someone has patient information on a calendar in the health system and that got exposed to a Google Calendar, it could get picked up and end up in the cloud.
Free busy as in, are you free? It doesn't have to be.
We talked about that, and I think some of these things, as we move into the environment, might get revisited to see how far we can go to make them work and still be compliant. So, free busy, maybe that would be a possibility. We actually worked at how we could actually exchange the data so that it was robust, and decided too much risk.
But I just want to follow up and confirm that particularly research faculty at the health system will be able to be part of the university's Google system.
So the question was, will the researchers in the health system be able to be part of the Google system?
We are currently part of, I have accounts at umish.edu, and I also have accounts at medical school where I take care of patient business, and I in fact have accounts at the VA where I also have employment where I take care of VA business. So we're already in a world where we keep these things, we have to keep these things separate.
So I'll answer that instead of repeating the whole question. Right now, the policy that has been approved, as I said, is that medical school personnel would not be provided Google Calendar and email in the UMich domain. They would be provided all the other Google apps. If a faculty or staff member wants Google Calendar or email, there will be an exception request process. And if there are a really large number of exceptions, Dr. Peskovitz has said, then we'll come back to the table and look at how to handle that.
I would point out to you that if it's hard, then what people will do is go get regular open Google accounts.
Absolutely. Absolutely.
We actually see eye to eye on this, but I would like to offer support on sort of senior people at the medical school to try to do something about it. Because I think it's potentially a really big problem.
So I think the way to do that is if we can collect the demand, that it would make a convincing case. The university has these competing business needs of openness for research, but compliance and protection of patient information. And so if there is a demand, some units that handle EPHI have said, we're gonna put our faculty in Google, and to help make it clear you can't use it for patient information. And that's how they're gonna handle it. So there still may be opportunity.
I want to point out that these are not policies that Laura, as CIO, has made unilaterally. She has presided over an extremely complex process, and it's and I would encourage you, if you think these policies are overly restrictive, or that you should make sure your academic unit management knows about that. And So that's, these are decisions that are being made at the unit level, not by the CIO. And as you point out, and I have pointed out in numerous meetings, if you can't get Google through UMich, you have it in your pocket. So, that ultimately comes down to trust.
Andrew Rosenberg and I, Chad, have been working with Dr. Hofer, and we will continue to do so to provide the information necessary to allow us to, adjust our policies based on, what the demand pool is.
Yeah.
We expect there will be, and there's different demographies, obviously, with the students, for example, many of whom are already using Gmail.
Yeah.
Medical students and so on. So it's a complex issue.
Yeah, I mean, if you take away nothing from this session, it should be that we are genuinely trying to develop a very open, responsive to the mission, responsive to the needs approach to IT provisioning and strategy here, not top-down. So your preferences, your needs, and so forth, you need to be clear in communicating those. Any other questions?
And we actually have not communicated the exception process, the way we can collect the demand, and so that we're developing that. We'll be working with the medical school to develop that, because the decisions on exception will belong to the compliance office, not to me, not to us.
General policy of not having medical school faculty be provisioned is not known among researchers. So I think one of the functions of this group is to actually sort of say, hey, you should realize that your unit has decided this, and it may have an impact on you, and you may want to.
Excellent, we'll do that. That's excellent.
Well, we actually, only yesterday morning did we get the formal approval from the executive officers to go forward with this plan. So this is really late-breaking, lately it's hot off the press. There's a question over here.
Regarding the openness of the system again, how accessible will things that are on the Michigan Google domain be to people not in Michigan or not having an account specifically in that domain? Because one of the concerns I brought up when the discussion was going around campus about having either Google or the Microsoft stuff was the ability to collaborate with people at other institutions. Because right now I'm sort of having trouble occasionally when I'm trying to pass data back and forth from my lab to other labs, them to send me stuff. So, is that going to be facilitated by this, or is it still
Yeah, Dan said it better be. He meant facilitated, not just as difficult. Our goal in doing all of this is to make that problem better, is to improve that situation. And so when I talked earlier about the things that I blew out on that map of our fragmented infrastructure, we recognize that the ability to collaborate, not just within the university, but around the world, is a challenge. And that's why one of the first things that we're moving to the cloud is the collaboration platform.
Okay, I think we'll.
Are we going to take a break?